Okay, another example from 7.1a. We've got negative 5x minus 3 over 8x squared minus 3x. And looking at the bottom there, it looks like it's going to be another one of those types where we can factor out a greatest common factor of x and work with what we've got left. So just to see how they break it down in the tutor mode, like we usually do, we got 8x squared minus 3x, and we're thinking about setting that equal to 0 to find restrictions. The process we've looked at is basically using a method of factoring, and we come up with a factor of x when we pull it out front. After you factor out an x from these guys, in parentheses, you would have left an 8x minus 3, and you divide that x out of each initial term. So 8x take away 3 is in the other box. And when you solve each little equation, the one with the 0 is already solved, so we can say 0, comma, and then when we solve 8x minus 3 equals 0, add 3 to both sides, you'd have 8x equals 3, divide both sides by 8, you'd end up with 3 over 8 is equal to x. So 0 and 3 over 8 are the restrictions. Okay, another difference of squares problem. Let's just do this one quick talking through without the tutor mode. Difference of squares, x and x, 2 and 2, that fit into a plus minus factoring scenario, and it would end up being 2 and negative 2 when we solved set equal to 0. So 2 comma minus 2. Once you get the hang of these, they tend to be pretty quick. Here's one right here. We don't even have to really go through the steps in the tutor mode again, because look at this. This doesn't factor at all, 3x minus 4. It is what it is, so if I just set it equal to 0 and solve, I'd add 4 to both sides. I divide both sides by 3. Our restriction would end up being 4 over 3. Okay, now you can do these little steps out on paper. I'm just kind of talking it through, but it's good to reinforce it, to write it down. Again, we got negative 5x squared plus 6 over 8x plus 5. I know there's something up top here that would normally matter, but I'm just focused on restrictions, which is just related to zeros on the bottom. If I plug something in, I don't want that to happen, specifically on the bottom. If I were to set that equal to 0, subtract 5 from both sides, divide both sides by 8, I'd have a restriction of negative 5 over 8 for that one. Okay, what if it says negative 6x squared plus 1 over 11x? 11x is our focus. What would make that 0? Well, if I set it equal to 0, I'd have 11x equals 0. To get x by itself, it's multiplied with 11. I divide by 11. I get 0 over 11, which is 0. So it kind of makes sense. If I were to plug in 0 for this, 11 times 0 is 0. I don't want that to happen. So this is one of those instances where 0 is going to be the problem value, because when I plug it in, I'm going to get 0. That doesn't always happen. Sometimes 0 isn't a restriction. It's just the result always has to be, the result of 0 is the problem. Okay, this one's one with the factoring, because we look at that, it's not quite clear how I'm going to get that to be 0 on the bottom, the restrictions. So if I go to the tutor mode, we'll go through their steps. I mean, I could basically talk you through maybe without doing the tutor mode on this one, because it's one of those basic problems to factor, basic trinomials with a lead coefficient of 1. So you can just say, can I think of two numbers that multiply to give me negative 20, and see how this is a minus minus? I'm expecting specifically because this is a minus that my number combinations are going to be opposites, a plus minus combination. And so I say, well, two numbers that would multiply give me negative 20, and then add up to negative 1. The negative 1 is in front of the x here. So I would say negative 5, positive 4. That combination would work just fine. So I can say x plus 5, excuse me, whoop, I said minus 5 plus 4, and then I started typing the opposite. X minus 5, x plus 4. And if you solve each little one out, subtract 4 from both sides up here, you'd end up with a negative 4, so it's kind of an opposite. And if you add 5 to both of these, you have 5 is equal to x. So negative 4 and 5 are your restrictions. Okay. Another example where you could just say, here's the bottom, set it equal to 0. If I divide both sides by 8, I'd have x still equals 0. So 0 is the restriction there. Okay. And on this one, look at how this one is set up on the bottom. I don't have a constant term, I just have 3x squared minus 9x. I can pull out a greatest common factor. It looks like a 3x. Let's see how they do this, how they show this. I say 3x squared minus 9x. I'm thinking about that being set equal to 0. And they say, what are the factors? Well, 3 is the greatest common factor. X is the greatest common factor. When I pull that out, divide it away, you're going to be left with x minus 3 in the other factor. So what are my restrictions? Well, if I took this one, I divided both sides by 3, I'd still get 0 as a restriction. And if I added 3 to both sides on this one, I'd end up with 3 as a restriction. Okay, so I'm going to go back through the practice mode just for a second because we went through the whole lesson really on video, but I'm going to look at some sample problems because there was one type that I didn't see, and maybe they've removed it in this newer version of the software, because there used to be a type of problem that had no restrictions. You see, you have that choice there, and I don't see that problem listed anywhere. I'm going to pause it just for a second, I think, and see if I can find one, just so you can see an example of it. Well, I just scanned through it 5 or 6 times, and I couldn't find anything that gave me the no restriction option, even though they give it to you. But just so you would know how something like that would look, I'll put a little paint thing on here to show you my own little example. Okay, I just created a couple of quick examples. If you had something like just 5x plus 8 over 3, and you were asked, what are the restrictions in this fraction example? Notice that there's no variable at all on the bottom. So that's a quick indicator that if I plug something in for x, there's no way I could end up with 0 on the bottom because there's nowhere for it to plug in. Kind of makes sense there. So that would be no restriction on that particular rational expression. This one here, you've got what looks like the potential for a restriction, but look at the bottom there. It's not, you got something squared and something else squared, but it's a plus. Okay, so sometimes these types of problems, you could get something like this thrown at you where you could say, well, I can't factor that. And the real true logic of it, to know that there's no restriction, is that if I square this, if I square something, let's say I plug in something for x, and just focused on the bottom here, I squared it, it would make it positive. or at the least it would be 0. If I plugged in 0, I square something, it would stay 0. And then I add 1 to it, there's no way that I'm going to end up with 0 as a result. Okay, you have a positive number pretty much, you add 1 to it, it's going to stay positive. You're not going to have 0. So something like that would be a no restriction case as well.